Today we are going to discuss about the important concepts and also a model paper solutions of a second sem math video syllabus with a subject code BMAT E201. Let us go through a module 1. The module 1 is act as a passing package for this scheme because it has a very easy topics like a vector calculations and also a Green's method and also Stokes method. As per the video scheme, we know that module 1 is consisting of two questions, question number 1 and a question number 2, and that each question is consisting of three sub questions. Here we are discussing an important topics for question number 1, means the what are the based on what topics the question might be asked. For a question number 1, we are having mainly 4 topics, which is known as find the angle between the two surfaces and find the divergence of a vector or a curl of a vector and show that a vector is a solenoid or a irrotational. This is the most important questions. This is the pakka questions in the video exam. And the last topic is directional derivatives. Based on these 4 topics, only the questions are asked in a question number 1. As we discussed earlier, important topics based on that, now we are solving a problem. These are the model question paper problems, and the first one is find the angle between the surfaces. The first surface equations are given: x y square z is equals to 3x plus z square and 3x square minus y square plus 2z is equals to 1 at the point of 1 comma minus 2 comma 1. Let us solve this. Consider the surface equation which is known as an x y square z is equals to 3x plus z square. Transpose the 3x and the z squares to an LHS, which is known as an x y square z minus 3x minus z square is equals to 0. And consider the second equation also: 3x square minus y square plus 2z is equals to 1. Transpose the 1 to this, which is known as an 3x square minus y square plus 2z minus 1. Then phi 1 is equals to x y square z minus 3x minus z square, and a phi 2 is equals to 3x square minus y square plus 2z minus 1. We know that to find the angle between the surfaces, we know that the formula which is known as cos theta is equals to delta of phi 1 dot product with a delta of phi 2 divided by magnitude of delta of phi 1 into magnitude of delta of phi 2. To find the delta of phi 1, we know that dou by dou x of phi 1 I cap plus dou by dou y of phi 1 j cap plus dou by dou z of phi 1 k cap. Now we need to differentiate the phi 1 with respect to x, such that when we differentiate phi 1 with respect to x, which is known as y square z minus 3 I cap plus differentiate phi 1 with respect to y, which implies that 2y xz j cap, and differentiate with respect to z, which implies that x y square minus 2z. They have given phi 1 point at the point of which is known as 1 comma minus 2 comma 1. Substitute the point which is known as y square, which is known as minus 2 square, 4 into 1 minus 3 I cap plus 2 into minus 2 j cap plus 1 into minus 2 whole square minus 2 into 1 k cap, which implies that answer is I cap minus 4 j cap plus 2 k cap. Delta of phi 1 is equals to, this is the answer. Now solve the delta of phi 2, which is the same formula, which is known as dou by dou x of phi 2 of I cap plus dou by dou y of phi 2 of j cap plus dou by dou z of phi 2 of k cap. When we differentiate this equation with respect to x, which implies that 6x I cap plus minus 2y j cap plus 2 k cap. They have given the point x, y and a z, 1 comma minus 2 comma 1. Substitute those things, which implies that 6 into 1 I cap plus minus 2 into minus 2 j cap plus 2 into k cap, which implies that 6 I cap minus into minus plus 4 j cap plus 2 k cap is the equation of delta of phi 2. Now consider the equation which is known as cos theta is equals to delta of phi 1, which implies that I cap minus 4 j cap plus 2 k cap dot product with 6 I cap plus 4 j cap plus 2 k cap. Then we need to find the magnitude of phi 1 and a phi 2. To find the magnitude of phi 1 and a phi 2, we need to square the coefficient of an I, j, k respectively, which implies that a magnitude of phi 1, which is equals to square of 1 plus 4 square is minus 4 square is 16 plus 2 square is 4, which is known as 16 plus 4 20 21 root 21, and delta of phi 2, which is equals to the coefficient of I, which is known as 6 square is 36, and j is 4 16 plus 4, which implies that 20 20 plus this root 56. Substitute here, delta of phi 1 is equals to root 21 into root 56. The dot product of an I cap is 1, such that 6 into 1 is 6, minus 4 plus 4 into plus 4, which is equals to minus 16, and 2 to 4, divided by root 21. Root 21, I will write it as root 7 into root 3. And root 56, we can write root 56 is equals to 2 into root 14. When we solve, which is known as minus 6 plus 4, which is equals to minus 12. Minus 12 plus 6, which is known as minus 6, divided by root of 7 into root 3 into 2 times of root 7 into root 2. 1s are, which is known as 2 1s are 2 3s are, which implies that minus 3 by 7 root 6 is the answer. Cos theta is equals to, and theta is equals to cos inverse of minus 3 by 7 root 6, which is equals to theta is equals to 100 degree, approximately equal to 100 degree.